Good day everyone. We are the group 6 that will be presenting the sensor-based water waste collector. Good day. We are so excited to present our project to you and keep you interested. But first, let's assess why we came up to this project. As we all know from Manila Bay before, that is full of mess way back. It's not the only water bodies that is suffering in a dirty, wasted state. With that scenario, we thought that if humans can clean their waters manually, why not let our artificial intelligence do the work? And that's where JellyBot, a sensor-based water collector. Why did we call JellyBot? Because if you think so, jellyfish tends to stick to other surfaces, which jellyfish tends to do. It makes the water waste to stick to its grip and grab it for collection. Enough with introduction, let's go to the main event, which is JellyBot. I'll be putting the different explanation by parts for the explanation of the project. First is body, scope, strengths and limitations, and recommendations for possible improvements.
Hi, my name is Perry Salazar from Group 6. With the budget purpose in mind, the body is made of polystyrene foam, which is the general purpose is to hold products like food equipments that is known as heavy and fragile to carry. It is also a clear, hard, and brittle foam that will be the best foam to use in this project.
I'm Deljan G. Pangan of CPT32. The main brain of the project is the Arduino Mega 2560, which consists of 52 digital pins and multiple voltage. Ground pins, which is overpowered for this project, but we will be discussing why we use Arduino Mega for this.
For the battery that will be supplying the electronics, there's a 3 separate battery holders that holds their purpose. The first two is 3.7 volts 3300 milliamps that is placed in series connection to create a much higher voltage, which is 7.4 volts, that is connected to the motor shield, which will be used to the BO motor's yellow to make the body move. There is also the same two 3.7 volts batteries, but with much lower milliamps, which is 2200, is used to power up the motors to the railings. We use lower milliamps as it will be just moving without a weight, as the motors below of the body will be moving backwards and forwards, which tends to drain batteries more. And for the last battery is a power bank. Yes, a power bank. I researched multiple articles that it's the best practice to use different batteries to a motor driver and to a Arduino, and decided to go with this setup.
Hello, my name is John Sexton. For the rings, we just pick a home-use grip liner. It works like a metal railings but with less price and hard work to set up. With the help of acrylic and a plastic tube used to hold the grip liner. With the motor moving upwards, the railings is now finished.
For the wheels, it is reinforced with iron tubing that holds the wheels to the motor, which makes it more durable and rotating. Same with the front wheel, but it's steel tubing, which is much bigger than to prevent wiggles, while the back motor is moving forward and backward.
Let's discuss the scope of our JellyBot. The scope of our project is to collect water waste, which can be found on lakes, rivers, and some small water bodies. We only tend to let JellyBot to travel on water that is not the same level with the platform. With that, we only detect the obstacles that may encounter of our sensor, and not detecting any waste that can be found on the water. Within 50 centimeters of the obstacle to the sensor, it will automatically steer to the side that is without the obstacle. Next is the strengths of our JellyBot. First one, with bigger body, it can accumulate larger waste from the water. Second, it it is future-proof as it's using Adreno Mega that have multiple pins and can accumulate multiple additions of hardwares. Third, wheels are enforced with iron and steel for better and efficient movement stabilizers. Fourth, budget-minded products that made easier to create and build. And the last one, minimal manpower as it's mostly place and stick or paste parts. Of course, there will be a limitation. For the limitation of JellyBot, I will be discussing it and give some recommendations on what possible changes that can be done. First one, it is using a distance-based sensor which makes the patting relying to the code that makes it steer and move. Second, the bigger body and the use of styrofoam which is light makes the body more prone to powerful winds to move it. Third, railing is too highly angled which makes some of the bottles to roll back down. Fourth, the destination is too inaccurate as the wind and waves become a huge factor of the robot's path. With that said, to answer the limitations, I intended to make recommendations on what part we can change to make it more durable and usable in some cases. The first one is GPS and compass. This is a good choice here as it will be determine the path of the robot, which makes more sense as water is a vast scope to determine the path. If you remember the Arduino that we used in this project, we tried the basic GPS. It needs multiple serials communications that can only be found on a Arduino Mega, but the GPS outputs inaccurate values, which makes the robot to think it's going to the correct path, but it's worse than the pathing instead. Make sure to buy a much better version of GPS to get accurate values of the path. We could have used smaller body which lesser wall to prevent air impact that makes the robot moves towards the air. Adding more weight to the body will make the body holding to the water better. Third, for the railings, we can add more length to it, making it more ideal for the battles. And the fourth one, to answer the fourth limitation, is the same with the second recommendation, which making the body much lesser height and creating more weight to it. And to end our presentation, here's the sum of the videos that we took while testing.